Hello everyone and welcome to the Utilities session at the 2020 New Zealand Esri User Conference. Thank you all for joining. Over the next 90 minutes, we'll be showcasing innovative ways in which New Zealand utilities have harnessed the power of GIS to meet their business needs, as well as highlighting some new technologies. By the end, we hope that you will walk away having picked up a new thing or two that you found useful and that you can apply to your own organizations. My name is Megan Cheong and I'm part of the GIS Technical Solutions team based in Wellington, and I'll be your MC today. Before we begin, just a little bit of housekeeping. We do encourage you all to ask questions and we welcome your feedback. So type in questions at any time by clicking on the Ask icon on the bottom left of your Chime platform. And just a note, plenary questions will be answered in the resources section at the end of the day. You can also use the note functionality in the platform to take notes, and remember to send them to yourselves afterwards. The platform will be available for 2 weeks after NZEUC to view recorded sessions and resources. I seem to have not shared my screen. Just 1 second. Apologies for that. Okay, here we go. All right, screen is sharing now and in presenter mode. Oops. Okay, sorry about that. So, as I was saying earlier, if you have any questions, please don't be afraid to ask and ask them in the Ask icon on your platform and at the bottom left. And you can also use the note functionality to make notes. And the platform will be available for 2 weeks after NZEUC to view recorded sessions and resources. So today we have a very good lineup of speakers showcasing New Zealand stories, as well as some guest speakers from the US and even content from the UK. In today's agenda, we'll be starting off with my colleague Dan Clark introducing the theme of the session, which will be based on the 5 utilities industry missions. Following that, we will have a special video from our sponsors GBS before we launch into the 5 user stories. So each story will touch upon one of the 5 missions: safety, asset management, grid modernization, innovation, and the customer. After that, we'll be taking a look at some demos of the latest technology, as well as getting a sneak peek from Esri about the road ahead for network management in ArcGIS. And to finish off, we'll have a Q&A session featuring my colleagues in the utilities team at Eagle. So with that, let's start the session with Dan Clark and GBS. Over to you, Dan.
Thanks, Megan, and hello everyone. Thanks for joining us for the utilities session. What an interesting year 2020 has already been, and while our normal way of life may have changed in many ways, we've seen a rapid acceleration in change as organisations adjust to the new operating models of this new normal. On top of the global events, utilities are facing many other challenges that are impacting their industry. With the advancement of technologies and adoption of things like smart water, battery storage, microgrids and IoT, it is recognised that the networks that we have today will not meet the demands of the 21st century and beyond. But utilities are on a transformational journey. It's important to remember that this is a journey that requires a strategic vision and supporting infrastructure. They still have to manage and invest in solutions that solve the traditional utility problems, things like aging infrastructure, poor data quality, and meeting customer satisfaction, while they also look to meet the demands of the modern utility, things like decarbonisation and electrification, as more and more customers come onto the network, as well as more types of assets and infrastructure. All of these things combined are part of that transformational journey that utilities are undertaking. Let me take you through an example of what I mean. Let's start by looking at some of the information sets that are familiar to many utilities. If you look at the slide, you can see things like asset data, customer connections, network designs, and the connectivity of your network. And you would probably agree that if you had all these data sets and your data quality was good, you would most likely be able to operate your utility. These data sets typically reside in your corporate OT or IT systems, and you have access and control to this information. These data sets are what a traditional utility are familiar and comfortable with managing. Let's now look at what a modern utility is typically contending with. A large number of data sets and information sources, including things like weather feeds, vehicle monitoring, traffic, battery storage, population growth, solar, imagery, LiDAR, so on. This data is different. It is unstructured. It's big data, both in volume and velocity, and most importantly, it's not often known by the utility. I hope this makes sense because this is a really important point to understand. The data and the information sets we manage in a modern utility are fundamentally different to the data sets we've had to manage in the past when managing the traditional utility. So what is GIS's role in all of this? Well, as you know, to create relationships between data and information, we need some sort of unique or common identifier, allowing our reference to build relationships. But as mentioned on the last slide, this data is unstructured and there's no common key as you may not own this data. This is where GIS comes in because it allows you to integrate all these different data types and formats using location. It doesn't matter whether it's tabular, imagery, CAD, 3D, real-time or multi-dimensional data. GIS provides a common reference system that creates the content and the context through the power of location. And for utilities, we're seeing significant adoption of GIS beyond the traditional design and mapping departments and moving into areas of asset management, customer care and operations and supporting the industry missions. And GIS is unlocking many new capabilities in areas such as 3D, imagery and drones, AI and machine learning. And it's these location enabling technologies that are greatly helping to streamline and automate many of the legacy utility business processes. Which brings me on to the theme for today's session, the 5 industry missions of a modern utility, which are applying best practice asset management and adhering to industry standards. Safety first. We want to be able to visualize real-time hazards in analytics, for example. We want to sharpen the customer experience, and we want to enable IT and operational technology interoperability as part of network modernization. And of course, we want to innovate and future-proof the utility. So the speakers we'll hear from today will be telling their stories of how ArcGIS supports their industry missions. Now, I want to talk briefly about the utility network. As you know, Esri released a new data model which is purposely built to help utilities achieve many of the things I've been talking about. This is the utility network, and it is enabling technology to help utilities and telecoms manage modern networks through a modern GIS. So let's start by looking at an electric network. It models and manages the entire electric system from generation all the way down to LV. You can model facilities that you don't own, but want information about. For example, a distribution company will need to know where the existing transmission facilities are, even if they don't own them. You might also want to know what generation is feeding your system, even though it's owned by someone else. The utility network model can support these information needs and also manage all the emerging technologies like distributed energy resources and microgrids. If we can continue to the next scenario, looking at gas utility, we see the same complete network from generation beginning at the wellhead all the way down to the customer. And just like the electric grid, we also see the introduction of renewable assets like green hydrogen or carbon capture storage, if that ever comes to New Zealand. All these new data sets are able to be managed and modeled in the utility network. Now we also bring in the telecom and cable network. We can begin to visualize the relationships that exist for the critical backbone of communications and how they can overlay the telecom and cable networks with other infrastructure assets in their customers. If you look at the bottom of the slide, you'll see that we are modeling the more traditional fiber networks on the power lines with drops to customers, but we're also able to represent how customers move into fixed wireless options as well. And we can model some of the small cell networks and 5G rollout. And finally, for a water utility, GIS is becoming a pillar for smart water or intelligent water. We see the creation of a modern intelligent water system from the source through production to consumption at the customer. A modern GIS allows us visualization across domains to visualize water infrastructure with water resources, wastewater and stormwater. Now we bring this together and we see the emergence of the IoT revolution and the ability to bring all these data sets into a control room or a single point of entry. This creates the ability to communicate and collaborate and make decisions on real-time data. And this is one of the strengths of GIS, bringing all these data sets into the control room to make better real-time decisions on how you manage one of these modern networks. And that's the power of the modern utility network. This is not multiple utilities running separate applications. This is the one data model that has the capability to traverse and bring all these different industries and all these different domains together under one network. And to help guide utilities to the utility network and achieve many of the things we've talked about today, I'll now pass over to our session sponsor, GBS, for a few words about an exciting new partnership developed just for utilities. Thank you.
Thank you. My name is Tony Elson and I'm a Director of Geographic Business Solutions. GBS is a professional services company dedicated to delivering world-class solutions, and as a gold partner, we are proud to be a gold sponsor of this event and also to sponsor the utility stream. Over the next 2 or 3 minutes, we're going to briefly introduce the Utilities Advantage Program, or the UAP, which is a joint initiative between Eagle Technology and Geographic Business Solutions. with a need to maintain and deliver better information to customers, regulators and employees. Change is sweeping the utility industry where information systems are required to deliver high performance, more elaborate detail and greater scalability. The ArcGIS utility network function provides a new foundation for utility GIS solutions to meet these unique challenges in this particular market space. So therefore, Eagle Technology and GBS are the gold standard team of professionals most qualified to deliver on your utility business needs. And this is why Eagle and GBS have joined forces to offer the UAP to the New Zealand utilities organisations. And having attained the utility network specialty recognition from Esri, Eagle Technology and GBS have essentially created a centre of excellence for utility network implementation, where we can deliver a proven methodology to ensure success. And as you can see, our methodology consists of a 3-page pilot, full data migration, and deployment and ongoing support. The UAP will help deliver key components of the utility network management functions, which you can see on this slide, and will no doubt be covered a bit further in detail by Aaron from Eagle Technology and the Tech Updates team. In terms of the program itself, the 3 steps for piloting a utility network are what we believe will ultimately deliver a successful implementation of this function. This will give organisations confidence in their asset data, knowledge and understanding, efficiency and compliance on their network assets. Data readiness means QA of the overall data and includes attribution, connectivity, network rules, with a report on what should be done and how to do it. Pilot migrations mean a cut out of localised data to ensure for a rapid prototype and to display what a successful implementation looks like and also illustrate the core capability. And the utility network preparation means preparing for the next steps, including what the appropriate environments might be, whether it be cloud, hosted or on-premise, and producing detailed project plans and details and overall costs. Last, please feel free to contact us on the information as per the contact details on the slide. And given that we can't have a networking event physically, on behalf of GBS, I'm just going to open a bid. Thanks very much.
Thanks, Dan and Tony. Thank you, Dan and Tony. For those of you who've just joined us, welcome again to the utilities session. We just have an overview of the utilities missions from Dan Clark and then a GBS video, who are our sponsors today. So like Dan mentioned, the utilities industry will be required to address challenges such as aging infrastructure and changing requirements, all of which need a flexible and robust modeling system to accommodate the changes in growth. The ArcGIS utility network is one solution for future-proofing your utilities, and it moves beyond the traditional utilities and to areas such as operations and asset management to allow you to make better decisions from real-time data. So please get in touch with us or GBS to learn more. And we also have a utility network video series on our Eagle YouTube channel that you can check out as well. And that link can be found in the resources section of the Chime platform. I'm happy now to be introducing our first user story, which focuses on safety, more specifically the management of hazardous vegetation and overhead lines. So this will be a joint presentation by Well Networks and Clarion. So I'm going to pass it over now to Mark Weller to share with us how Well Networks leverage mobile apps to safely and efficiently manage over 3,000 kilometers of overhead power lines. Over to you, Mark.
Hi, I'm Mark Keller, the Field Delivery Manager for Well Networks. Well is the 6th largest distributor of power in New Zealand, and we supply to over 93,000 households, businesses in Waikato. We're 100% community owned, and part of our job here is as a field team, Well needs to manage any potential safety risk posed to overgrown trees and other vegetation to about 3,420 kilometres of overhead power lines. Next slide. So what Clarion has done for us is, here's our snapshot of our dashboard. So this is real time. When anyone sees this information, will update. It provides me with the pending hours, so how many hours we've got in the pipeline for the work crews, the average job hours, so that's currently sitting at 3.4. We have a hotspot map of where our vegetation is going to cause us issues in the future. And I've got a map of where I can see all the work that's been completed in the Clarion system. This is a screenshot of our Clarion mobile system. This is used by our inspectors and our field teams. Our inspectors insert the data into the system, including any hazards that may be on the sites. And our field teams are able, when they get assigned work, are able to use the GIS information to go exactly to the job. And when they've completed the job, they complete the job card and sync it back into the system. With that, I'm going to hand over to Chris, CEO of Clarion. Thanks, Chris.
Thanks, Mark. My name is Chris Kelly. I'm co-founder and CEO at Clarion, and really happy to be talking to the New Zealand GIS community today, and extremely grateful for Mark and the WELL team for co-presenting with us. Clarion has been working in GIS and vegetation management since 2007. We work with utilities across the country to help them with their vegetation and asset maintenance and inspection programs. So just a quick overview of the WELL work process. Mark described this a bit, but I'll go into a little more detail. But we've got applications and tools for the inspection or work planning process, creating job orders, doing field work completion, and then of course the dashboards that we saw at the beginning of the presentation. So the inspection planning process allows us to take circuits out into the field that are assigned for patrol, and the patrollers and the planners can identify work tasks at each property or land parcel, and also review reactive tickets that have come into the system. That information flows back into the desktop admin software, where the program administrator can build electronic job packets, assign work for the week to the crews, and also provide order to work details and site instructions so that they can coordinate with other parties that are necessary to safe completion of the work. As the field crews receive work through the application, crew leaders can use the GIS and GPS to find their assigned job sites, coordinate with third-party traffic control contractor for safety, and also coordinate with the WELL network system controller to set the reclosers into the safest position for the tree work near the power lines. The crews can then indicate job completion and record any details, and all that information comes back into the central GIS available to the admin and to the dashboard users. Here's just a snapshot of the crews in action. And with that, I'd like to turn it over to Jeff Walker, who is the project manager for Clarion on this project, and he's going to walk us through a quick demonstration of the software.
Hi, my name is Jeff Walker. I'm a project manager with Clarion Software, and today I will be demonstrating the WELL Network's vegetation management workflow using the Clarion applications. So the WELL Network's workflow essentially starts inside our Clarion mobile application. This is an application where a patroller can place work features on the map where tree work is required. And so the entire property selected, turned into what is called a work site, and then work features are placed on the work site to show where the tree work is actually needed. So we have a property here on the left, and then we have another one on the right. And if we zoom in on the one on the right a little bit more, we can see that a trim was placed on this property. And the colors basically symbolize the status that the work is in, whether it's pending, assigned, completed, audited, rework required, or utility complete. And you can see that on the legend on the left. So once the inspector has identified work locations, the next part of the workflow is inside our work manager application. And it's more of a table-based application where administrators can see work that's been identified by the patrollers and can begin to assign that work out to crews. So In this view here, we have our worksite panel. And in the worksite panel, again, this is all the work sites that have come in that have been identified by the patroller. And so then what the administrator will do is they will assign a date for that location and an order for that location, a daily order. And what that does is what they're doing is they're building out an actual schedule that the crews will then follow, so they know that they can be on location, on the property when they're supposed to be doing the work, and they actually can do it in the correct order for the day, the different properties that are scheduled out for the day. Once the work has been scheduled out by the administrator, the work then will go out to the tree crews to perform the work. And the way that the crews receive their work is back inside the Clarion mobile application. And so once they have these, this list pulled up, so they can go ahead and start with their first item, they can select that item, and it'll bring it up in our object properties, which show the properties related to that work location, and they can go through and get some more information such as address, property owner, what type of equipment's needed, again, can confirm the date and the daily order, and then any kind of traffic control that's needed as well. So once they have this selected, they can zoom to that location on the map, and when it loads, it'll pull up the information that's related to it, such as the property boundaries and where the actual work is located. And so then what they'll do is they will drive out to that location, the address that is listed on that work site, and go out and do the work. And you can see here that this one is in a completed status, so they have finished the work. So the crews arrive on site, get the details related to the property. There's a notes field where they can get any kind of information that's relevant to that property. They also have the patroller who identified the work in case they need to get a hold of them if they have any other questions about it. But essentially they will get to the property, read the relevant information for that property, perform the work, and then move it to a completed status.
Thanks, Jeff. I'd now like to transition the conversation to talk about Clarion's technology roadmap. The demo you just saw from Jeff was deployed late last year prior to the official launch of our new runtime application. This new runtime application aligns with the direction of the Esri platform and takes advantage of the new web service-based architecture that Esri is building on. The Clarion Field app is configurable, and it is a cross-platform application. By cross-platform, we support a bring your own device model as well as company-issued devices for Windows 10, Apple, and Android as well. We support online and offline use cases, meaning that if you're in a connected environment, your changes will be recognized by other users real time, as well as offline where there's no data connection, to allow you to have the full functionality in the disconnected environments. I'd now like to highlight some examples beyond what we're showing here right now. We also support worksite planning. So if along your assets, you need to identify prescriptions on a property-based level, you could identify removal points, brush points, brush areas, things that align with your prescription planning out in the field. Lastly, if you're not tracking individual work tasks on the property level, you could also track progress by span as another approach to monitor your crews working along your feeders and assets as well. That concludes our presentation today. I'd like to thank everybody for attending, as well as for presenting with us. If you need more information, please contact us at sales@clarion.com, or you could get in contact with Eagle Technologies as well. Thank you again.
Thank you for that. It's always great to see a full workflow from work planning to job creations and then field work and then visualizing that latest information back in the office. And that's certainly one of the advantages of a GIS system. So EAGLE is also working towards an official partnership with Clarion to bring better vegetation and asset management more in line with the New Zealand market. So stay tuned for that. Next, I'm pleased to be bringing our See What Others Can't campaign winner back to the stage for our asset management story. And David Haberkorn of Powerco will be sharing with us in depth how they rose to the challenge of more efficiently identifying areas of their network for renewal, and how they went about using the ArcGIS platform to create a tool bringing together different sources of data into an easy all-in-one solution for better asset management. So over to you, David.
Good afternoon, everyone. My name is David Haberkorn, and I work as a GIS specialist at Powerco. I'd like to thank EAGLE for giving me the opportunity today to give you a short overview of the Powerco overhead renewal planning tool. I'll start with a short overview. Powerco is New Zealand's largest electricity distributor in terms of network length and has the second largest number of electricity connections. Our network covers large parts of the North Island, of which many are rural and remote. Much of Powerco's network was built during a period of intense development that occurred in the 1950s, which saw many rural communities supplied with electricity for the first time. These networks are now at an age where condition and performance is deteriorating and renewal is required. To respond to this need, Powerco is executing a substantial renewal program funded through a customized price path approved by the Commerce Commission of New Zealand. Identifying and prioritizing overhead line assets for replacement is not a straightforward task. Renewal need is only loosely related to age and is highly dependent on other factors such as material quality, environment, past maintenance practices, visual assessments of condition, fault history, and many more. The large asset footprint combined with a fog of information from diverse and sometimes sparsely populated sources makes it difficult to see where investment is most needed and how work should be packaged to create projects of an efficient scale. These difficulties lead to subjectivity and inefficiency in identifying and scoping projects. Therefore, required a tool helping our planning engineers tackling all these issues. Our solution combines diverse sources of available data to produce visualizations that inform where network renewal is most needed. Our approach uses grid binning, where hexagon-shaped bins are assigned a score based on weighted combinations of input variables. Calculations include past faults, defects, observed condition scores, asset ages, and known problem asset types, also known as type issues. The resulting scores enable visualization of network condition as a heat map, providing rapid and compelling insight of renewal need. Differing sized hexagon grids and bins enable higher resolution needed when moving from a macro network view to a localized project view. Asset condition is not the sole criteria for renewal though. We created another hexagon layer showing the potential impact of asset failure. Again, information from diverse sources was combined to visualize the previously unseen, predominantly the number of customers potentially affected by equipment failure, and census-derived population density as a proxy for likelihood of equipment failure causing injury. The condition and criticality layers were then combined to produce a third layer visualizing asset risk. By visualizing the abstract quantity of risk, our planning engineers can balance trade-offs and target investments where they provide the greatest benefit for improved service levels for customers and improved safety for the community. This insight is used to scope and shape efficient renewal projects that target resources where they provide the greatest cost benefit. However, point type assets were only one part that we needed to investigate for our renewals. Overhead conductors, the wires in an overhead network, are traditionally one of the more difficult asset types to assess condition and plan for renewal unless you look at samples coming back from the field. In this work, we tried to create additional insight to the conductor renewal problem by developing a predictive model to estimate conductor health based on expected life, environmental factors, and data available on historical failures. We did that by creating a health score for each individual span between two poles using an industry standard modeling methodology known as the Ofgem Common Network Asset Indices Methodology, or SNIME as short. The SNIME methodology, while free to use, is normally implemented using enterprise asset management systems or simply spreadsheets, with outputs being tabular data and summary statistics. We didn't want to go that way. We didn't need another spreadsheet from hell. So in this work, we took a novel approach of implementing the SNIME algorithms within ArcGIS. What that means is that we can go from a map like that only shows our conductor voltage to a map like that. And that's our current predicted health score over the whole network. On top of that, we can also look into the future and see what happens in, for example, 5 years if we do nothing on the network. So how do we actually implement the tool? Well, the project made extensive use of the integrated ArcGIS platform applications and tools. All models were developed in ArcGIS Pro and then scripted using Python to add customizations in the development of features specific to the modeling required. This was also used to create a Python toolbox that enables our planning engineers to run and tune the models by editing parameters within the application. The models are also configured to automatically publish feature services, as well as write to databases for business use after being validated. ArcGIS Insights was used to produce summary statistics and visualizations to aid in summarizing, calibrating, and navigating the models. Our renewal projects are shared by using our Powerco operations dashboard. Finally, the collector and survey 1-3 apps provide a feedback loop that allows field observations to be cost-effectively incorporated into the modeling to provide validation and continuous improvement. And this is how it works in practice. We can run our tool either on demand or as part of a schedule, and the tool will look at various data sources as well as parameters that we can set. Now, running the tool will give us results, and for the results that represent our heat maps, we're not really concerned about validating them because they're all based on hard data, so they're all good to use. However, our conductor model is a predictive model, and that means we need to make sure that we have a high enough accuracy for what we want to do with the results. So we need to validate the results against some ground truth data. And we do that by either comparing our model results with samples that come back from the field, or we go out into the field ourselves and do visual assessments, collect some data, and compare the collected data against our model results. We can then go back, tweak our parameters, and run the model again to improve our model performance. Now, this is a really good use case for applying some machine learning in AI, and we would definitely like to look into that in the future. But also from what we've seen so far, just using our knowledge and comparing it against samples, the model seems to be performing really well at this stage. The ability to virtually look down on the network and see previously disparate sources of data combined to produce views of asset condition and risk has transformed the way that planning engineers identify and package network renewal projects. A task that previously took months and involved a large degree of subjective judgment can now be performed in days based on logical and consistent rules driven transparently from available data. This new efficiency has enabled renewal planning engineers to prepare a significantly larger portfolio of planned renewal projects with longer forward lead times, assisting in driving procurement and delivery efficiencies. The conductor modeling represents a step change in engineering insight available for this asset type. The new insight is informing changes in strategy, which in time will improve safety and service level outcomes for customers.
Thanks, David, for the deep dive into how you identified the need and all the way showing us the business implementation using insights, dashboards, and field apps. I know many of us wanted to learn more after hearing about your tool in the plenary session, and Powerco's overhead renewal tool is certainly a great example of using the ArcGIS platform to improve asset management by consolidating different data sources, and it's great to see how it's already made an impact and increase the efficiency of renewal projects. So thank you again, David. Speaking of consolidation, our next user story has undergone a transformation from their bespoke legacy systems into a more modern, highly scalable and integrated platform. So Eastland Group have undergone a modernization of their existing GIS and IT systems by integrating both ArcGIS and SAP S/4HANA to produce a seamless platform to meet their needs. So let's go over to Jason Grout of Eastland, who will walk us through their new setup. Over to you, Jason.
Eastland Group is a group of companies, including Eastland Network, our electrical lines business, Eastland Port, an international log export facility, Gisborne Airport, generation, including 2 geothermal plants, no modest hydro. Our vision through Project Highway was to consolidate and integrate data, standardize processes, automate workflows, implement mobility, and to decommission legacy systems. While our bespoke legacy systems had faithfully carried us for many years, they lacked scalability or were unable to be projected outside of our physical domain. Using the SAP Geographical Enablement Framework, or GEF, delivers us a seamless environment integrating our Esri content with the S/4HANA content, giving us a consistent style, symbology, and branding across all user interfaces. The GEF basemap can show imagery, but for this video, we'll retain the New Zealand light canvas. Methodologies, as you'd expect. Select an asset, object, use the ellipsis to expose actions, push those actions through to SAP to expose technical objects, attributes, notifications. An additional option we thought useful was the addition of Google's Street View. That added additional confidence to the user that they were at the correct location. At left, you can see that content can be exposed or hidden using the business layers selection. Additionally, multiple features and object types can be selected, confirmed, and passed through to SAP. And from there, further actions can be completed. The ability to find objects is obviously a core requirement. The GEF search options are comprehensive, allowing wildcard or specific locations. Additionally, from there, the selection can be pushed through to SAP for further processing. And again, and perhaps finally, an example of using search criteria to widen the search. ZAG's product BlueWorks has been selected for data capture in the field. This is Esri UK's Utility Network Editor Beta. The product's using Esri's Naperville demo data, which shows how a field editor can access the data, maintain it directly in the system, maintaining topology, validation, and built-in business rules. The field worker can see downstream and upstream components and how they're connected. And they can add and edit new features in the field. While not demonstrated here, the application boasts context and object-dependent menu options. It's an extremely clever interface. Eastland Group sees significant value in this product, but have not landed a decision on implementation at this time. And now to the cool stuff, the Esri Utility Network. Our legacy data model was authored in the late 90s, built as a flat data model, and was accessed through Microsoft Access. As part of Project Highway, this was initially migrated through to SQL Server and a geometry added to it. From there, the ZAG Esri team analyzed that input data model, advised dependencies and relationships. And from there, derived an FME model to effect transfer of that legacy data into Esri's utility network model. Now, Eastland Group initially investigated the Esri utility model, piloting an initial data cut with Eagle Technologies. And I take this opportunity to thank Eagle, Aaron Sapsford, for that initial work. And from there, the result. Note that the symbology is preliminary only at this stage. We haven't put much work into this at the moment. And again, a shout out to the ZAG team. Throughout this project, the ZAG Esri team have been outstanding. And for a novice user like myself, extremely supportive. And again, the demonstration through here, showing the connectivity. And again, some limitations. The QA system we're showing here only has the legacy UID at this stage. This is the ZAG web mapping application that Eastland Group are using. Built by ZAG on the latest Esri JavaScript API and Facebook's React JavaScript framework. This is Eastland Group's portal for ArcGIS. Through Portal, Eastland can control access to content, external websites, web mapping applications, services, and other data sources. Login is authenticated through Portal for ArcGIS and is how we control access to which data layers, as users can only see web maps that have been shared with them. Address search is through Esri's World Geocode service, but we can configure this to use our own geocoder if necessary. When we identify features, the results come up in a drawer, here on the left. You can see we have 6 results returned, and as we scroll through, Each selected feature is highlighted on the map. There is a deliberate spelling mistake here for asset group. In WebMap and Portal for ArcGIS, we can fix the alias for the field. All data and information within this application, including pop-up windows, is authored and secured through Portal for ArcGIS. Reloading the page, we can now see the field spelt correctly. Users can also view location on Google Street View. Users can also draw, measure, on the map. And the drawings can be printed out or downloaded as KML, GeoJSON, or shapefiles. The addition of the transparency slider is a really nice touch. At footer, we have terms and conditions and contact details, which are easy to change and configure as necessary.
Cool, thank you for that. Integration of existing IT, OT systems with new technology is a common issue with utilities organizations. So it's good to see Eastland and ZEUC showcasing their data interoperability to deliver a highly scalable system of record that they can then leverage in flexible ways, like in the custom web app. You would have also seen Jason briefly talk about the utility network editor from Esri UK. We'll take a closer look at that in the tech update coming up. But next, let's welcome back Dan, who will talk about IAMSL and how they've revitalized their current workflow through innovative uses of the ArcGIS platform. Over to you, Dan.
I'll be giving a quick overview of how IAMSL are using ArcGIS as part of their innovative solution offering to their customers. Infrastructure Asset Management Systems, or IAMSL, specialise in overhead line inspection, design and management, and provide consultancy services to power distribution companies in New Zealand and Australia. They have a dedicated in-house specialist UAV team for asset inspections. Their team can get close approach distances to assets to obtain both high-definition still photos and video. The data is then compiled and analysed by the team of engineers, and a simple report is delivered to customers, identifying what faults may exist and the urgency by which these faults need to be addressed. Now, the problem that needed solving was that apart from the UAV, the entire workflow was non-digital. This would lead to difficulty managing images being captured and matching them to the correct assets, reliance on paper-based data collection and manual report creation. This led to inefficiencies in their workflows. But by using a simple ArcGIS-based solution using out-of-the-box tools, solved these problems and also gave them the ability to collaborate and share data directly with their customers. The solution basically consisted of three main components: ArcGIS Pro with models and tasks for feature layer publishing and drone image attachments, Collector for field-based collection of notes and setting inspection status, and the Pole Assessment Control Center, a story map series with embedded dashboards and Survey 123 forms. But the key to all of this was a single hosted feature layer in ArcGIS Online that was used in three separate web maps: the Mobile Pilot web map, Pole Inspection web map, and the Pole Assessment Reporting web map. So keeping things simple with a single feature layer to power all of these maps. So let's step through the workflow. Step one is the project setup and loading of client data using the project setup task. So again, with keeping things simple, IAMSL are not skilled GIS operators, nor do they plan to be. So something as straightforward as adding features such as pole locations to a map can be a daunting and uncertain task if you're not familiar with the tools. The solution here was to take advantage of the built-in Task Assistant Manager in ArcGIS Pro. For those of you that are not familiar with this, the Task Assistant Manager is an ArcGIS extension that is used to create step-by-step instructions to standardize the completion of GIS tasks, as you can see in the video here in the Task tab. So a number of tasks were created to guide the user through the process to set up a new project and add original pole locations provided by the customer as either a shapefile or a feature service, and copy them into the pole assessments data feature class with a required schema for completing the inspection workflow. With the feature class updated, and because a single dataset powers multiple web maps, we can see the data across the solution, in this case within the drone flight status dashboard, one of the tabs within the pole assessment control center. So here the users can see metrics on complete versus incomplete drone flights and filter the view based on pole attributes such as pole material and pole installation date. But once out in the field to complete the drone pole inspections, step 3 is for the drone operator to use Collector to set the drone flight status and capture additional assessment notes. This gives the operator a companion app for simple field capture of field notes that had previously been carried out using paper. Not only does this prevent the double handling of data and syncs automatically with ArcGIS Online, with that one feature class, remember, but it also allows them to capture supplementary photos and observations from ground level if required. These field notes can greatly help the engineers back in the office when they come to do the detailed inspection of the drone images. And of course, for anyone back in the office, the drone flight status can be viewed in real time on the drone flight status dashboard, and the field notes coming in from the drone operator can also be viewed. But once back from the field with the drone, the task is to load all of the geotagged images into the GIS for inspection. However, with many photos of each pole, they needed a way to associate the correct photos with the correct pole. There's no primary key, but with the photos being geotagged, location was used to create these associations. In ArcGIS Pro, another task was configured to guide the user through the steps to first import the drone images, allowing the user to load in a whole folder of images at a time, and then to attach the images to the poles as a photo attribute. This uses GIS to associate each of the photos with the correct pole based on a 10-meter buffer rule. The 10-meter buffer rule assumed that if a photo is within 10 meters of a pole, it would be added to the pole as a photo attachment. Now, we could have determined the correct pole by using the orientation of the photo, that is, capturing its metadata, but the 10-meter buffer gave us the results that were needed. Now the drone images are available for inspection by the engineers through the control center. It's worth noting that the workflow in ArcGIS Pro in performing the tasks is carried out by the one person. For most people, they would be using the pole assessment control center. So this is that story map with tabs for different apps. There are a couple of dashboards, an image attachment viewer, and Servo 123 for data entry and tagging. So we've already seen the drone flight status dashboard, and here we can see the drone image viewer, where the photos for each pole can be viewed in high resolution. So this is a place for the engineers where they come to carry out the drone image inspections and eyeball the images in full resolution alongside any field notes. Next, they do the final assessment using the pole assessment survey. There's a list of poles ready to be checked, and the engineers can still reference the images in full resolution while they complete the survey form. The survey form itself is an embedded Servo 123 form that captures the required information to complete the assessment. This is driven by the single feature class mentioned earlier and populates the fields that were created by the task way back in step 1. A future enhancement here could be to include the use of ArcGIS machine learning to automatically recognise and flag issues to automate the pole assessment survey. But for now, we have completed the inspection workflow. So now the inspection is complete, the results now need to be shared with the customer so that they're able to incorporate the findings into their decision making. There are 3 main ways that this has been achieved. The first is via a dashboard that is shared with the customer, providing interactive views and metrics that can be explored as we can see on screen here. The second is a more traditional approach of sharing a physical report. Servo 123 includes a report generator which can be used for this purpose. Using a report template that has been set up to replicate the look and content of the existing paper reports that IAMSL had been using previously, Servo 123 was able to generate the report in Word or PDF format for sharing with the customer. A future enhancement here could be to include the use of webhooks to automate the report generation and distribution that is triggered when the survey assessment is submitted by the engineer. The third way is sharing the layout securely through ArcGIS Online directly with the customer. In this example, we're taking the role of an asset manager at Top Energy. From within their own corporate ArcGIS Pro, they can connect to the secure shared feature service that has been shared with them from IAMSL's own ArcGIS Online. This allows them to use their own GIS for further analysis and reporting, and this could also trigger interoperability to update fields within an EAM or ERP system, for example. So that was just a quick overview of a simple but effective workflow that has increased the operational efficiencies for this innovative organisation. Some key things to note were that there's a focus on simple to use workflows and using software as a service that incorporated web and field mobility. Some future enhancements that were mentioned were possibly using machine learning for image assessment and webhooks for automation. But there could also be the addition of full motion video to complement the still photos. I hope this has been a useful overview. Thanks for listening, and back to you, Megan.
Thanks for that, Dan, for providing a great overview of, like you said, a simple but effective workflow. It really ties into the theme of that utilities are going towards of digital transformation, especially with moving away from paper-based workflows and into using field apps and dashboards. I'm sure many of us have seen similar use cases, but no matter how straightforward it is, it really can bring the value to utilities in terms of reducing data entry errors and increasing operational efficiency. So thanks for that. Okay, our final user story will be, in fact, a twist on one we all saw in plenary. Energy Queensland's Look Up and Live app has already proven to have saved lives. Eagle is very keen to create a similar app for New Zealanders, and so we are calling on New Zealand electric utilities to collaborate with us. Let's hand it over to my colleague Sam Williamson, who will give us a quick tour of what we've already been working on. Over to you, Sam.
Hey, thanks very much, Megan. Hey, it's good to be with everyone here this afternoon at this virtual Esri user conference. So I'd like to talk to you a little bit about the Look Up and Live New Zealand application that we've been developing here at Eagle Technology. It comes off the back of a story that we've all heard this morning in the plenary, but which we listened to early on this year. The story of the lookupandlive.com.au map that was developed by Energy Queensland. This application was a web mapping application that brought together electric distribution overhead lines in the area of Queensland, including lines from Ergon Energy, Endeavour Energy and Powerlink. And we really love the story about how it's really making an impact and a real difference in saving people's lives. It's a really easy to use application where people can come along, search for an address or a location of where they're about to do some work with high loads, and just understand whether or not there's some overhead lines in that area. And if there is, providing some easy to access information about where they can go to understand more about those overhead lines or apply for high load permits. So when we heard the story, we thought we could give it a crack here in New Zealand. And so we've begun doing that. We've registered a website called lookupandlive.co.nz and have begun creating a very similar web application that people can come ahead and use. And what we'd like to do today is just give you a sneak peek at that web application and then give you some more information about how you might be able to get involved. So this is the Look Up and Live NZ mapping application. And you'll be able to find this at lookupandlive.co.nz. And once you're loaded into the application, you'll be prompted with a splash screen and which just lays out the terms and conditions of using the application. But as you can see here, we've used this mapping application to bring together a lot of already publicly available layers, including transmission lines from Transpower. And we've also loaded in the distribution network boundaries. And this serves as a nice countrywide layer, which includes the name of the electric distribution network in your area, as well as links off to the website, phone number, and a specific link out to safety information and tree trimming information. So in this case, this is the Eastland network website. What we've done with the application is made it easy to use as possible, including buttons to zoom in and out, find your location, and changing the base map as well. So here we're just switching the base map from that canvas style base map over to the Esri imagery base map. Now, what we've been doing with this prototype Look Up and Live NZ application is working with Unison Networks Limited. So they too were really interested in the project that was happening over at Energy Queensland, and based off some health and safety drivers, they wanted to help us configuring this Look Up and Live NZ application as well. And so what they've done is they've shared their overhead power lines data with us via ArcGIS Online. And then we've started to amalgamate all these different data sets into this Look Up and Live NZ application. And so now we've got not only the transmission lines, but the distribution lines here as well from Unison Networks. You can bring up the legend as well and understand a bit more about the voltage ratings and whatnot. So the purpose of this application is really to understand what the distribution lines are around the area that you're working in. And so you can type in the address of the anticipated area that you're going to work in, and then zoom down into the map. And what we've done here is we've actually done the same thing as Look Up and Live over in Australia and generated an exclusion zone, just as a visual cue there. And so, as well as loading in all the Unison Networks lines data, we've also loaded in a bunch of links that they wanted to have in this application, including a link out to applying for a high load permit. And so all of those links are available in the pop-up when you click on the different high voltage or low voltage overhead lines. So Unison Networks covers a pretty broad area. And so what we want to be able to do is actually go out to different distribution networks and work with you guys to bring in your own overhead lines data into this Look Up and Live NZ application. And to make that easier, we've included a button up here in the top right where you can add your lines to the map. What this is just a simple form where you can add in some of your details so that we can get in touch with you and discuss how we can actually get your overhead lines into this single application. So you can put in your name, organization name, contact number there. And if you've actually got an existing public feature layer with your overhead lines data, what you can do is go to ArcGIS Online or maybe grab your open WFS services if you have those, and grab the URL to those overhead lines services and actually paste them into this form. And then we'll have that handy, and after we get in touch with you, we can discuss how we can actually incorporate this into the mapping application. So this mapping application is actually built with the Experience Builder, which is a nice new application which gives us access to a couple of nice new features, including being able to rotate the map, vector-based maps, but it's also a 2D and a 3D application. So what we've been prototyping here is how can we actually kind of envision using 3D in the future as more and more LiDAR available comes online, and maybe using BIM or 3D lines data. How could we really utilize that and provide a really rich experience to the public, understand a little bit more about heights and overhead lines. In this use case here, we've just loaded in some procedurally generated transmission lines that our friend Gert did down in hardware. And you can toggle back and forth between 3D and 2D mode as well, but that's just a little prototype feature that we're working on. And so while we've only really worked with Unison Networks in this case for the Look Up and Live NZ application, we can bring together existing publicly available lines data, including the transmission network. But what we really want to do is engage the electricity industry here in New Zealand and talk with you guys about how you might be able to bring your overhead lines data through to this application using ArcGIS Online or any open services that you've got, and really fill in the gap and provide a single destination where people can come along and understand a little bit more about health and safety issues with overhead lines. So like I showed in the demo, there's a nice easy way for you to get in touch with us by clicking on the button, adding your lines to the map, adding in a feature layer if you've got one already. And the whole idea here is that we can bring together or federate a whole bunch of ArcGIS feature layers or WFS services using ArcGIS Online into a single web map, and then provide that out and serve that out as a single application that people can come to. So that's just a quick demonstration of the Look Up and Live NZ. At this stage, the Look Up and Live application that I demonstrated isn't live yet. If you want to contact us and get more information about that, then get in touch with Dan Clark. His email is dac@eagle.co.nz. Hey, thanks very much.
Thanks so much, Sam. That was awesome. I really like the 3D element that you added there, and using Experience Builder instead of the Web App Builder. Thank you, and thank you especially to Unison Networks for sharing their data with us. I think we can all agree how impactful an app like this can be. So please check out lookupandlive.co.nz to try it out and submit your own lines data. So that was the final user story. I'd like to thank all our presenters so far for sharing their awesome work with the New Zealand utilities community. Now it's time for technology updates. For the first part of our technology update this year, we're pleased to be showing you a new way to enable your workforce to interact with the utility network. You would have seen a glimpse of it in Eastland's presentation, but let's explore it further. So coming all the way from Esri UK is a new lightweight web app called the Utility Network Editor. And it's built on the latest JavaScript 4.x API, which is fast and allows anyone from anywhere with a device that has a browser to access the utility network, to interact with it, edit, update, view the single source of truth, and maintain your network connectivity. Because the utility network is based on a set of business rules, the editor allows you to make edits that are immediately validated against these rules, meaning data is valid at the point of entry. Esri UK have also developed this app with the goal to enable anyone, GIS professional or not, to be able to use it. And it is currently in beta mode, but in the upcoming months, Eagle are working to showcase the app against your data, against New Zealand data. So watch out for that. So let's take a look at the app in action to see how intuitive it is. Firstly, there's no long installation process to get started. The Utility Network Editor is a lightweight app and runs in any web browser. This one is open in Chrome. This means you can access the app from any device that has a browser, whether it be a tablet in the field if you're a field worker, or in a desktop back at the office. You'll notice that there aren't many buttons or tools available. The team at Esri UK have worked hard to ensure that the interface is intuitive and simple by making sure the app understands the actions of the user. If I select a pipe, you'll see that more tools that are relevant to the pipe will appear. So I only see tools as I need them. Along the top are the most commonly used tools needed to interact with the network, such as viewing connectivity associations and containment features. Along the side are tools to further enable you to explore the data, such as seeing the properties of an asset and performing traces, which we will cover in a bit. Tools that are less commonly used are stored at the bottom, taking up the least amount of space. So I'm going to assume the role of a water engineer, and I want to add a new service connection. So to start, I want to add a site plan to my map. I can drag and drop the image straight into the app. Then I can resize it, and I can even use georeferencing to accurately overlay it over my site. Now that it's added and that I'm happy with it, I can use it to add my new service connection. The utility network is based on a set of network rules, which means every single edit is checked against them. The editor was built to understand this, but it also goes further by applying them each time you interact with the network. So what does this look like? One rule we have in this particular utility network is that residential service connections connect to valves. Once I select a residential service editing template, the editor recognizes that rule and highlights for me all the valves, giving me immediate visual feedback and helping to guide me to make valid edits. So this therefore reduces the need for lengthy and expensive QA post-processing. Now I can switch on measurements and refer to the dimensions that I've marked on my plan in order to accurately add it. Cool. Before doing so, I want to explore the network rules by opening up the network pane. This allows me to double check all the rules that apply to my service connection. I'm happy with that, so I'm going to add my new connection, and it only took a couple of minutes. Due to the configuration of network rules, I haven't just created a pipe. I've created a connected asset which myself and anyone else at my organization can immediately access. And I can see all this connectivity. Selecting the pipe I can view all its connections highlighted for me in the map. And the great thing about the utility network editor is that all of this is taken from the rules of the utility network. So if any rules change, the app will automatically apply them without any input from the system administrator or end user. The utility network editor also allows you to run traces and create schematic diagrams. So to show this, I'm going to switch over now to Naperville in the United States and explore their distributed electric network. The first thing I'm going to do is open up my trace panel, and then I'm going to select a starting point for this trace. For this trace, we want to perform an upstream trace. The trace executes. Now you can see all the features which are selected as part of that trace. What can we do from here? Well, to me, it's a good idea sometimes to look at the network from a different point of view. So I want to see the trace results in a network diagram. What I can do is open up the diagrams panel and I see the schematic generated for me. Useful for engineering workflows. So I can interact with the diagram, find out more information about an asset, and view it in the map. So that was a quick sneak peek of the utility network editor from Esri UK. So I hope you all can see how intuitive and accessible that was. So like I mentioned before, stay tuned as we are planning to utilize the utility network editor with New Zealand data. Esri recently released ArcGIS Pro 2.6 and Enterprise 10.8.1, and one of the highlights of the new features in the utility network include non-spatial objects. Network configurations such as fiber or electric underground networks can contain a very dense array of geographic features, sometimes too dense to model spatially. The introduction of non-spatial objects allow for another level of granularity. And to show us more about non-spatial objects and to talk us through the road ahead for network management, let's pass it over to Larry Young from Esri. Over to you, Larry.
Hello everyone, Larry Young, Program Manager for the Geodatabase, here to talk a little bit about the non-spatial capabilities added to the utility network with Pro 2.6 and Enterprise 10.8.1. So we're here in ArcGIS Pro and we're looking at our sample communications network downloadable from our solutions site. And what I've done is taken this network and upgraded it to support non-spatial objects. So you see here some standalone tables that are the new non-spatial objects added to this network. If we look quickly at the network properties, we can see within our structure network, we've added a new structure junction object and structure edge object class. Within our actual telecom network, we've also added the junction object and the edge object. So what these are, or what we call again non-spatial objects, what's interesting about them is they're actually rows in a table without a feature, but they can participate within the network index. If we look at our connectivity rules for junction edge, we can see where we've defined where these edge objects, in this case, fiber strands, where they connect to actual features in our network that have shapes. So this is how these non-spatial objects participate in the network. So let's take a look. Let's zoom into a particular area, in this case, an access terminator assembly. And we can see in the existing communications model where features are used, how each of the individual fiber strands connect to ports. Down here in the lower right, I've started converting the strands that were features to non-spatial objects. So you don't see any objects down here. But what I can do though, is to add a trace flag onto this port, and I can perform a downstream trace, and I can trace through the non-spatial objects, starting with the one connected to this port. So if I look at my attributes here, you can see all the things that are returned from my trace, and we can see that we returned a couple of edge objects from that trace. Those edge objects are contained within drop network cables, so we still can locate those spatial objects, and we can see where this trace terminates actually at this customer location here. If we zoom into another bookmark along this trace route, our drop terminator assembly, we can see the actual ports that were used for this trace. Now what I want to do now is to provide additional service to a new customer. So I'm going to clear my selection here, and I'm going to use create features. I'm going to use this group template that I created to drop a new fiber cable that's going to contain a strand, and it's going to contain all the customer equipment. So let's zoom out a little bit here so we can add that service. Zoom out a little bit more. Again, make sure we got this active. And let's start by connecting to our drop terminator location. We'll use some of the existing structures. We'll pan up a little bit here. One more connection to our assembly, and then we'll finally end up here at this customer location. So what this group template does for me is it lays down that drop terminator cable, lays down the non-spatial object or a fiber strand inside of it. It also lays down the equipment to connect to the customer. So if we look at our attributes, what was actually created, again, we can see this edge object, this non-spatial object. So let's go ahead and select only that. But while I'm here at the customer location, I'm going to set a flag for our next trace. Now, what I'm going to use is our modify associations dialog here, and I'm going to load in our strand. And I'm also going to go back to our drop terminator assembly where we started. And for our strand, we can see that we actually have a connection to our port at the 2 end. And what we had with that group template was an attribute rule that automatically created the connectivity to the customer equipment. Now what I need to do is to create the connectivity at the other end of that strand to an open port, which are these ports in white. So I'll go ahead and select an open port. You'll see it added here to our connectivity. I can say that's the from end of the strand. I can apply that. I can validate my network index. So it's now burning that update into the network index. Now what I can do is go back to our trace dialog and say I want to trace upstream from that flag that I dropped on the customer equipment. Go ahead and run that now. And you can see it go through the port where we just made connectivity, come out the other side. And if we go back, we can zoom out to the full extent where we're going from that new customer all the way back to the source. So that's just a little bit about how non-spatial objects work within the utility network. Kate, you give me a few minutes to talk about the road ahead for network management within ArcGIS. As you can see, as always, we have a very full schedule. Try to hit the highlights. I'm going to start with the things that were just released in the Enterprise 10.8.1 Pro 2.6 release. I'm going to start with one of the biggest one here, which is non-spatial object support. What that allows us to do is to have essentially rows in a table that participate in the network index. This is very important for things that have a high volume of data, such as telco networks, where you don't want to have to represent every individual strand as an actual feature with a shape. Non-spatial can also be used for things like electric underground in dense urban areas and so on. Next thing I'll touch on is attribute rule diagnostics. Attribute rules become very popular as a way to automate the setting of attributes, a way to query underlying layers. It's also how you do validation when you're done with your editing workflows. We've added some diagnostics so you can manage and track the time that the attribute rules you have in your system are taking, how much effect it has on the editing process, and so on. Next thing is a enhancement request that actually came from your distributor there, Eagle, where they wanted the ability to have multiple structural attachments for a single object. So think about a transformer, for instance, that's on a platform between poles. So having that transformer attached to multiple poles. Next thing up is part of the support for taking the network offline. And this is what we call synced with name version. So when you take data offline and you want to use it in Collector or in the new Field Maps application, you want to be able to take out data from a particular version as opposed to posting directly to default. So within Enterprise 10.8.1 now, when you have your map pointing to default, you say you want to go offline, it automatically creates a version for you. Edits would then be posted to that version. The other thing I want to highlight that was released with Pro 2.6 is something called the Trace Network. And I want to highlight that because I want to make it clear that the Trace Network was designed for non-utility users. It was designed specifically for users such as hydro, stream networks, that sort of thing. Some people have asked about, well, could we use it for utilities? Again, that is not what it is designed for. The utility network is designed for use with utilities. So let's start with what we're working on then going forward. As always, we're working on quality and performance. Some of the specific things we're working on, though, a big one for utilities for years has been partial posting, or the ability to create a version with the design, let's say for new service in a subdivision, but only portions of that new services come online at a given time. So you want to be able to post a part of that design. So we're adding capabilities there into the SDK to support that. Since it's just in the SDK, that means we still need partner solutions on top. And we'll continue to look at that going forward to see if there's more we can do specifically within core for that. Version posting queue, that's the ability for the editors to do their design work within a version, and when they're done, they don't have to necessarily reconcile and post. They can just submit that version to a queue, and in time, each one of those versions will be posted. You can also specify when you want things to be posted, only post at night, that sort of thing. If conflicts are detected, that version is set aside. A manager can then come back and look at the conflicts and post accordingly. Create and store trace configurations. This is important for the disconnected workflow. If you're somebody out there in the field that wants to do a trace, again, through Explorer or Field Maps application, you don't want that user to have to fill out a bunch of parameters. You want them to be able to click on a specific trace that's already been configured for them. So we're adding capabilities to configure particular traces. For instance, I want to do an upstream trace stop at a protective device. Configure that trace, store it, make it available to the end user out in the field. As I mentioned, attribute rules are becoming very popular as a way to automate the collection of attributes, automatically query other layers, and so on. Most of the enhancements going forward will be in the arcade language, which is what's used to script attribute rules. So we're adding in this next release things like knowing what version the user is working on, knowing that current user. This would allow people to write attribute rules to maybe restrict edits for that particular user and that sort of thing. Query differences here, the final one, what that is important for is determining exactly what the changes are, maybe in default since the last time you exported data. So this is part of the workflow, part of the process of moving data from the utility network and ArcGIS into other systems. Again, it just makes it easier to figure out what the changes have been since the last export. So these are things we hope to get into the next release, which is planned for Q1 of 2021. Now, looking a little further out, things that we continue to work on are these first two here, runtime SDK support, disconnected networks, those sort of go together. That again is the ability to take the network out into the field in a disconnected manner so you can trace offline, that sort of thing. So we continue to push the runtime SDK, which then fields our off-the-shelf field maps applications and so on. Runtime SDK also can be customized by partners. continue to add more utility network capabilities there. Along the same line is adding support within the JavaScript API. Right now, of course, you can write web applications hitting directly against the REST endpoints, and we have partners that have been doing that. But we also plan to add support directly into the JavaScript API to make it easier to create those custom applications. Now, grouping and bundling of objects is an interesting one. Again, you talk about the telco market and the volume of data that needs to be modeled for strands within a fiber cable, for instance. We'll be looking at ways to optimize the performance. Is it necessary, if you have a fiber cable with 144 strands, to actually store each individual strand as a record in a table, or can you have one record that says there are 1 to 144 strands? We're just looking again at ways to optimize the overall performance of the system in that particular area of non-spatial objects and the volume of data there. Export subnetwork enhancements. I mentioned a minute ago how important it is to be able to figure out what has changed since the last time you exported data. What we're continuing to work on here is to make sure that we have the capabilities to export each important piece of information that the external systems need. So including things like association information, including things like containment, structural attachments, which again are part of the associations, including the geometries, all that sort of thing. So we'll continue to iterate there based on feedback from customers and our partners as to what they need to provide, again, to drive those other mission critical systems. And then finally, I've touched on this a little bit. I think everyone at this point knows Field Maps is the new application, off-the-shelf application that combines capabilities of things like Collector, Explorer, Navigator into one application. Soon we expect to have utility network support within that application. So by the end of the year, early 2021, you'll start to see utility network specific capabilities within that field map application. So again, thanks for listening. That's just a little bit about the road ahead. Hopefully I'll be there next year to present this in person. Thank you very much.
Thank you, Larry. There's certainly a lot of new capabilities coming our way, and particularly I think non-spatial object support is one to keep an eye on as it matures and develops further. And as more utilities modernize and move onto the utility network, it'll be interesting to see how the solutions evolve. So this brings us almost to the end of our utilities session. We've taken a look at 5 unique user stories, each touching upon one of the 5 utilities missions. To finish off, I'd like to welcome my colleagues to the call to answer any of your questions. Hello.
Hey Megan, how are you?
Hey Sam, how are you?
Good, thank you.
I think we're waiting on for Dan and Aaron. Hi Dan.
Hi.
Cool.
Hey,
Okay, so just looking at the time, we have 2 minutes left before the end of the session, so I'll just take a look at some of the questions that we've received. Okay. Okay, so I've got one question here. This person asks, do you see the revamped utility system allowing utilities to alleviate their use of systems such as Small World or other additional support systems, including Schneider including ArcFM? So who would like to answer that?
Maybe I could take that one, Megan. So it's best to understand that the utility network technology is very much a framework. And so the utility network that Esri ships includes functionality you need to sort of model your utility, whether it's water, gas, electricity, in a really high level of detail. So it includes all of the attribute roles and implicit connectivity, all of that good technology to sort of make that utility work. We also ship data models, which sort of help you to get started with that utility network, but there'll always be a need for a partner product to sit on top of the utility network for the actual end users of that utility network to interact with. And we've seen a couple of them today, like Esri UK's Utility Network Editor, which is a web-based solution. And we also distribute a solution here in New Zealand called ArcFM. So those solutions sort of sit on top of the utility network, while Esri is just focused on the underlying technology.
Cool, Sam. Thank you for your answer. Do we have time for one more question, maybe?
Hey, Megan, I'll just jump in. So I'm conscious of the time, and these utility sessions are usually jam-packed. So if anyone does have any follow-up questions, you can reach out to us here at Eagle by either emailing Dan, Sam, myself, or Megan, or utilities@eagle.co.nz. That mailbox is monitored fairly frequently, and we can get back to you with any questions.
That also applies if you have any questions for any of the presenters that you'd like us to pass on. Please send them through.
Cool. So that seems like that's what we have time for today. So thank you very much for attending this user utilities session. Thank you again to our presenters, and thank you to GBS, our sponsors, for today. We look forward to seeing you all face-to-face very soon, and we hope that you take care of yourselves. Just a reminder that all the content for the New Zealand Esri User Conference will be available for 2 weeks from now, and you can still continue to ask questions during these 2 weeks. So thank you, and have a great rest of your evening.